Hello student, how are you? I am Arun sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class, I will discuss you the relative velocity between two projectiles or the path observed by one projectile when it is observed from the other. That is path of the projectile of one with respect to the other. Now let's start about the class. Okay. Suppose two body projected from a ground. Suppose one particle projected from the ground, this is the ground, with angle θ1, and another projectile, another particle projected with velocity u2. Suppose this is u1 and this is u2 with θ2 from the ground. Now the path of this particle will be this and the path of this particle will be this, suppose. Now when we observe one particle with respect to other, suppose here a particle is present and here a particle is present. So when we observe this particle with respect to this, then what will be the path of the projectile? If we observe this particle and this particle from the ground, then the path will be this and this. But when we observe this particle with respect to this, suppose a particle along this and we observe this particle along this. So what will be the path of this particle when we observe with this? This is actually moving and its path will be the projectile. So from that point it is moving and it is moving. So when we observe this particle with this, what will be the path of this particle? Now let's discuss about the class. Now this is x-axis y, this is x, y. Now what is u1x? u1 will be u1 cos θ1 I plus u1 sin θ1 j. Okay, in terms of I and j we can write now u2 equal to u2 cos θ2 I plus sin θ2 j. I have told many times that when we discuss about the projectile, then we always resolve the velocity and acceleration along two direction, that is x and y direction. So we resolve the velocity and now we resolve the acceleration. Acceleration a1 will be minus j direction because acceleration act in this direction. So a1 equal to this and a2 equal to also minus this. Now we can easily say that relative acceleration equal to a1 minus a2, which is that is 0. Relative acceleration is 0. Okay. Now u12 means relative velocity of 1 with respect to 2. We can take any one with respect to other. Okay, u12 equal to u1 minus u2, which is equal to this minus this, that is minus u2 j. Okay, u12 equal to this. Now x component u1 to x component will be this and u1 y component is this. We get x component and y component. So now the relative velocity, this is a actually vector because it has some value. Suppose this is 3 value, this is 4 value. So relative velocity equal to 3i plus 4j. So we know this is a vector. So the motion will be along straight line. Along this. Suppose this is x-axis, y-axis, this is u1 2x and this is u1 2y. So if this angle is alpha, then particle moves along the straight line and whose angle with x-axis is tan alpha is given by perpendicular by base. Perpendicular is by base, that is u1 sin theta 1 minus u2 sin theta 2 by u1. This is the angle. Acceleration along this equal to 0 because relative acceleration is 0 and this is the angle, that is the particle, the velocity of particle when it is observed from other, it will move in straight line. In straight line along the path whose direction with the horizontal will be given by this. If u1 to x equal to 0, u1 to x means this, that is this, then particle moves along y direction, then particle moves along vertical. If there is no component of velocity along x direction, then obviously it moves along y direction, that is the movement will be the straight line along vertical. Now another condition is u1 to equal to 0, then particle moves horizontally. Condition is that u1 sin theta 1 equal to u2 sin theta 2. So if this condition is satisfied, then particle moves along x-axis. Condition of collision of two particle in air, that condition is that the relative velocity of one with respect to other relative velocity of one with respect to other should be line joining them. That is if two particle collides in mid-air, then VAB should be along the line joining between A and B, or VBA along B to A. Or BB along BA. So this is the condition. Suppose A initially moves with velocity u, suppose UA, and B with moves initial UB, then first find UAB. So to collide at mid-air, the UAB must be along this direction, UAB along this direction, or UAB along AB, or UBA along BA. That is the relative velocity of AB should be along this line, or BA along this line. The particle is projected. Particle is projected with an initial velocity of 60 meter per second at an angle 30 degree to the horizontal, horizontal. At the same time of a second particle, at second particle B is projected in opposite direction with initial speed of 50 meter per second from a point at a distance of 100 meter from A. If the particle collide in air, find the angle of projection alpha of particle B. Second question, time when the collision take place, and the question is the distance of P from A where collision occurs. This is the question. So this is the question. Now the diagram is this. One particle is projected with 30 degree and another particle is projected with 60 degree. So this velocity is 60 meter per second. This is 50 meter per second. Now the distance between A and B is 100 meter. The distance between AB is 100 meter. Now the diagram is that, suppose here a particle A and here a particle B. The distance between AB is 100 meter. A is projected with velocity 60 meter per second with angle 30 degree, and another particle is projected with 50 meter per second at an angle alpha. So this is the diagram. Now we have to find the angle of projection alpha, time when the collision takes place, time, and the distance of P from A. Distance of, suppose the particle collide at here, this is the P, this. So you have to find the distance with P from A, that is this. AP, B is suppose here P is at point, here collide. Now to solve this problem, we consider always B as at rest. So to solve this type of problem, always B is at rest. Always keep the velocity of B is at rest. Then if B is at rest, then the velocity VAB, what? VAB equal to UAB equal to UA minus UB. Now if we put the velocity at B, velocity of B is 0, then UAB means the velocity of U, that is velocity of A which moves towards the B. And another condition is that to collide the two particles at mid-air, the velocity direction of velocity UAB should be along AB. Now find UA. UA equal to 60 cos 60. This is this, that is So UAB equal to this. Now the direction to collide the velocity, to collision, to take to what is the condition of collision to collide the two particle, the direction of UAB along AB. So the direction of AB along the direction of UAB along AB. So this component must be 0. S direction, that is so allow the component, this is direction, this should be the direction, so this value must be 0, that is this equal to this. So for this we get sin alpha equal to 30/50, that is 3/5. So alpha equal to sin inverse 3/5. We know 3, 4, 5 and 37 degree. So 3/5, that is sin 37 degree. So alpha equal to 37 degree. So for that angle, if the particle B moves with velocity this with an angle 37 with horizontal, then the two particle collide. UAB equal to UA minus UB, which is equal to minus of minus plus. Now what is the condition for collision to collide the two particle? I have told previous that the condition is that the UAB, direction of UAB should be along the direction of AB. That is direction of AB we take, this is x axis, so the direction UAB direction would be this, along this direction, so this should be 0, so for collision UAB direction would be this, that is 30 equal to 50 sin alpha, that is alpha equal to 3/5, sin inverse 3/5. This angle is 37 degree, this is 3, 4, 5, so alpha equal to 37 degree. Now take the particle B. If the particle, we consider that if the particle B is at rest, then UAB means the particle A moves with velocity UA along this direction. So we keep the velocity, so we consider the velocity of B is 0, that is B is at rest. Now the particle A moves with velocity VA along this direction. So if velocity B, if VB, if UB equal to 0, then particle moves with velocity UAB along the direction of AB. So we calculate UAB equal to this magnitude of AB. So magnitude of UAB equal to this root 3/2, that is now 3, 4, 5. This is alpha 3, 4, 5. So cos alpha equal to 4/5. So this is the velocity, magnitude of the UAB. Now the particle A moves with velocity this along towards the B and collide the B. Suppose B is at here and A moves with velocity this, so ultimate it collides with B. So now time taken, this is the distance 100 meter. Now the time taken to collide the B is distance by velocity, that is distance is 100 meter and velocity it moves with relative velocity UAB. So 100 by UAB means this. So this is the time taken. So after that time, the A and B collide. Now what is the distance of AB? Now at that time, distance moved by the velocity moved by the particle A is the distance level. So the particle collide here, X and Y. So what is the distance AB? B is 0. Now the UA X equal to 60 cos 30 degree 30 root 3, and UAY equal to 60 sin 30 degree, that is 30. So distance of AP square, which is X equal to AP equal to this root over this. So X equal to UAX velocity into time T, and Y is along Y direction. So this is UAY T minus half GT square whole square. So put here UAX T equal to, we get T equal to 10 by 4 plus 3 root 3. This is the value of T. So put here this whole square. So just put the value of T and you get the result AP. AP is the distance of the point T where the two body collide from the point A. So this is the distance AP. This is UAX. X means distance travelled by A along X direction, and Y means distance travelled by Y along Y direction. This is the distance travelled in X direction. In X direction there is no acceleration. So this distance X will be velocity into time, and Y equal to UT minus half GT square. So this is the result. In the given figure shown, the two projectiles are fired. A moves with velocity UAB, because UAB means UA minus UB. So if UB is 0, then the particle moves with velocity UAB. That is, now to find UAB, UA vector form, UA equal to 20 this is UA, UB equal to 20 cos 30 degree minus I plus, we take this along I and this is J. So root 3 by 2 J. So we get UA and UB. Now find UAB. Find UAB. UAB equal to UA minus UB. So this minus this. 5j minus 5j 0. Sorry. This minus this. So this motion, this is a vector. So this motion is along straight line, but it moves at an angle alpha with x direction. So this is A, this is B. The particle moves along this direction. This is U. Now the distance is 20√3. So if we find the angle, then what is the shortest distance? So B is at rest. B is at rest and UAB along in this direction. So what is the shortest distance? Shortest distance always perpendicular distance. So this is the shortest distance, BC. Now we have to find the angle alpha. This is A, this is B. Distance 20√3. So this is UAB. UAB, the component of 2 is UABX. Now this angle is alpha. So tan alpha, we get tan alpha equal to UAB equal to this by this. If we get the alpha, then the shortest distance will be this. Shortest distance will be this. So from the figure we get shortest distance. From the figure we get shortest distance BC. BC now sin alpha equal to BC by. So BC is the shortest distance. BC equal to shortest distance. So from that we get this. Tan alpha equal to, we get tan alpha this. From this we get sin alpha. So we get shortest distance BC equal to that's why we find the shortest distance. Shortest distance is the perpendicular distance. So B is at rest. B is at here and UAB, that is A, moves along the direction with the velocity AB. Now the shortest distance is perpendicular distance from B to this. So we have to find the angle alpha first. Now to find the alpha we have to find UAB. UAB equal to this. So this is the motion in straight line. UAB, direction of UAB in this, which makes an angle alpha with x direction. So we get tan alpha equal to perpendicular by horizontal component. So this by this we get this. From tan alpha we get sin alpha, and from that angle we get the shortest distance BC. Students, this is the end of the class. Subscribe my channel to get more and more videos. Okay, thank you. Welcome to my channel.